Well, good morning and welcome to our talk here. First, I'd like to thank the organizers of the conference for managing to hold it. This was not an easy thing to do, I am sure. Very complicated days, and so congratulations on doing that um, and getting us all together virtually, that's fine for right now. I'd also like to thank them for allowing us to speak today about our report. We're basically making a report about a report. Uh, the four of us studied the permanent magnet industry for essentially the last year and tried to put some things together to point out the size of the market, how it's growing, and all these other various things. So our point today is just not to try to sell the book, just to report a few things at a very high level that may be helpful in understanding what's happening. So how am I going to do that? Well, I'll introduce the authors to you. I will try to explain why we decided to embark on this project. And then we'll go over the high level things. People are always interested in growth rates and what kind of questions does your report answer and things of that sort. So we'll go over a few of those. We won't go over all the questions that we answered. We don't have enough time to do that. It's too much. But I will pick a few of them and we'll look at those. They become the next group of my soapbox points there, and so you'll hear me kind of wax philosophical about various things, and then we'll make some conclusions at the end. So my distinguished co-authors, Walt Benecke is one. He and I wrote a similar report about 10 years ago, and I guess we had so much fun we thought we'd try it again. Walt's background is mostly from Arnold. He's been a consultant for quite a while, like me, since 2001. Steve Constantinides has a little bit more varied background. He worked for Crucible and Arnold, and then some other companies in the ceramics and glass industries. And he's been consulting for the last 5 years or so, but still has a lot of magnet experience. John Omerod's a metallurgist like me, University of Manchester. Worked for Phillips and Arnold in the magnetics industry. Also ran a stamping factory in Wisconsin, and has been consulting now for the last 6 years. And for me, I've been around this industry a long time, worked at various places. Some are household words and some are not, but I've spent some time in the magnet industry and the rare earth industry. And I've been consulting since 2001, so 20 years now. Okay. Well, I don't know about you, but every morning I get a note from Google about searches that they've done in my behalf, looking for this and looking for that. And some percentage of the things that turn up are market studies of various kinds. And to me, I've looked at a few of them, and some I don't think I've read them, but some of my co-authors have, and chuckle when they discuss them, that they're really not very well done. And seem to cover a lot of ground that somebody will look at magnets one day and then mashed potatoes the next week, and try to make sense in both spheres. It's very difficult. So we were a little frustrated by that. We thought we would do a more intense and more thoughtful, maybe that's the nice word to say here, a more thoughtful study. So I like this quote from Lafayette. I went to his college. So it's one of the quotes that we get to see when we're students there. But I like it in this case. I think it does address where we came at things, that we tried to add as much common sense as we could. And we think that's the thing that's missing from a lot of other reports. When I went through and wrote an executive summary for the book, and one of the things I realized that we're doing in this report is we're answering questions. And so I went through and looked at each chapter and said, well, what questions are answered by each chapter? And so you see a list here of the ones that we think we've addressed. And I think we've hit all the kind of the topics that we should hit in a report like this, to try to be thorough, to try to predict the future, but also look at the current state of the art and where we've been, and kind of try to tell a story with it. The three that are highlighted will basically become my soapbox points in the next section, but the others are here. There's another page which I'll show you in a second, but it's got the rest of the topics in here. So again, things about research and development, new materials, patents, who the big players are, who makes equipment, who are the consultants in the industry. We thought that was a very important section, but you may not. And then quite a thorough, this last one actually refers to the appendices. We actually maybe went overboard in being very educational with this book, that there's a glossary and a section on the basics and some other things in there that really it gives a lot of background, and so I think it may be helpful for people that are relative newbies to the industry. Okay, so now into the soapbox points. We looked at, oh, I'm sorry, now into the heart of the matter. I apologize. Now into the 30,000 foot view, or 10,000 meters, depending on your perspective. But here we looked at growth by applications, and these growths are average annual growth rates. They're also done in dollars. I didn't put the dollar sign in there to designate that, but this chart and the next one are both in dollars. And you see the biggest growth rate we see is with electric vehicles. Obviously, there's a lot of interest in this area. I think the other thing that makes the growth rate a little bit high is the fact that it's still a relatively small industry. When we look at what percentage of vehicles on the road today are electric vehicles, it's still small. Wind turbines are the other ones that are the big application areas that people talk about with lots of growth. And this one actually comes out a little bit smaller, but it's because there are a fair number of wind turbines out there already, and many of them are using permanent magnets. So there's growth, and that's great. Growth in a more mature market is a wonderful thing, right? But I think the list, or the way things kind of tail off from lots of growth to not so much growth should make sense. These were all built from the bottom up. So we took sales figures from many sources and many conflicting sources. This was one of our biggest headaches, was trying to look at a lot of data that didn't always agree with other data that's out there, and then try to say, well, we believe this number over that number, and try to, like the earlier slide said, add as much common sense as we could to it. So the one thing I'll mention here with data storage is the growth rate is nil. That's actually not a bad thing. This is a mature, very mature technology. The big driver for data storage these days are server farms and things of that sort. We don't put hard disk drives with magnets in our laptops or our computers so much anymore, unless we demand an awful lot of storage, which is not my story, that's for sure. But there's no growth here, but that's okay. You know, I think one of the things I always tell people about our industry is that we have a wide diversity of applications. And that's really a very good thing, because things will grow, things will mature and ripen and maybe disappear, but there's always something new coming along. And of course, the driver we see is, I think, what everybody else sees, and it's energy efficiency. And so as we try to squeeze a little bit more efficiency out of things, it tends to push people towards using permanent magnets for motors and sensors, all the usual applications. I mean, we even see growth for internal combustion engines, and every day you pick up the newspaper and one other major car manufacturer will say, well, by some date in the future we'll be out of this business altogether. But in the meantime, we still need to squeeze as much as we can out of it, so we still see a little bit of growth there. In terms of material, and again, these are by dollars. If it were by weight, it would be a much different looking graph. But most of the growth is in neodymium iron boron. I don't think that comes as a surprise to anybody. The growth in those two materials is a little bit above the average. Ferrite in various forms is a little bit less than the average, but still healthy with all of these. Samarium cobalt still grows, because there are places where it definitely makes sense. I worked on it in my graduate school days, so I'm happy always to see it doing something. And even Alnico, there's a little bit of growth here again because there are places where it makes sense, and we need to take advantage of that. There's nothing wrong with a good Alnico design. So my three soapbox subjects now to kind of get into some of the questions that we address and how we are looking at things. So the first one I need to talk about is raw materials, because I think that's kind of the lingering concern. If we were doing a SWOT analysis of this industry, I think that would be one of the weaknesses that we would identify. And we tried to get a little bit more detailed about this. The thing that we could always use a little bit more of are what I would call the heavy rare earths, the dysprosium, terbium, maybe gadolinium if you want to throw that in there too. The resources for this are a little bit limited and small. These days, a lot of the heavy rare earths for China are actually coming out of Myanmar, and I'll talk about that in a moment about fluctuations and other instability things. It would be nice to have better geographic diversity and more stability out of those. The light rare earths, we could use more. I think you could certainly extract more from the current sources that we have. I don't find it particularly troubling on this point. Can we get more neodymium? Yeah, it would come at a price, and that's always the story in a business like this. If you want to be the one driving the show, making people are running mines to collect your particular rare earth, well then you're indirectly asking for the highest prices. The third point is one that doesn't come up in the magnet industry, but I will bring it up because I think it's a very big weakness. Historically, if you look at the rare earth market, there was no market. Rare earths were really isolated, separated, I'd say in the early 50s for the first time, and you were able to have, say, tonnage quantities. To be honest, people did not know what to do with them, and it took quite a while. It took a lot of work to identify places where they might go, and then slowly talk people into trying them and getting good results, and then finally developing a business out of it, a basic business development type things. The thing that's missing now is that the world is awash in cerium and to a lesser extent lanthanum. And I see a few projects out there that use a little cerium. You can use cerium as a partial substitution for neodymium. There's some water purification projects that use cerium. That's all nice, but we need something really big. And those two projects are small compared to what we really need to develop. Because people of late have gone in and sold rare earths by just saying, I will sell you this at a very inexpensive price. They really don't know how to develop markets, and that's a real lacking, I think, in the industry. To talk about resources a little bit more, lots of resources have been identified. This is what we call in the trade junior miners. Junior miners sometimes are the brunt of various jokes, but the serious topic is that they have a deposit, they have an analysis for the deposit, they may or may not have established on the bench scale a way to process the ore, but they've got a story and they're very excited about it. They're really looking for investors, and they need the money to bring this resource on stream, and then they have to go through the various obstacles of starting up a mine. There are environmental things you have to do, business things that you have to do. These are very capital intensive operations, and so obviously nobody's going to invest money in them unless they can see the return in what I guess I'll call a timely manner. Timely in this time with this type of thing is maybe 5 to 10 years. It takes quite a while to bring some of these things on stream. So in terms of a solution for, hey, this is going to solve the problem in the permanent magnet industry, this is a very slow moving one. And given enough time, things do work out if properly nurtured. But this is always a slow one. So let me look at one that's a little bit faster. I think one of the biggest ways that we can affect the raw material situation and pricing overall is to pay particularly close attention to the process of design and the material selection activity within that. In the past, I think we've always had this idea that magnets are engineered products. You can talk about magnets in terms of dollars per pound or dollars per kilogram or yen per gram, anything you want. But when the rubber hits the road, it's the idea that somebody slaps down the drawing and says, I want 1,000,000 of these parts, and this part will have dimensions, tolerances, magnetic characteristics, coating, other things spelled out on it, so that this is really an engineered product, and it's not something, it does it a disservice when you talk about buying it by the ton or something like that, because these parts are certainly not fungible. You can't go to the customer next door to the original customer and say, hey, do you want these? The way you might with topsoil or something else. It just doesn't work that way. So this whole process of optimization, I think in the past, has been really focused on two things, which are important: cost, and cost in the current moment, I'll say, rather than cost over the lifetime of the product. And then the other is trying to minimize the volume or the mass or weight of the magnet that's employed. These are good, and I think now people may look at this more as a starting point than the be-all and end-all, because I think we need to add this phrase at the end about with the lowest impact. And impact may not be either of the two things that I've mentioned. Somebody who demands a grade of neodymium iron boron with a huge amount of dysprosium in it for not a particularly good reason is really violating this by going overboard with their use of dysprosium. This is not helping anybody. And the way we really need to monitor this or try to understand this is I think the choice of the temperature range of the design is really where this whole thing starts. And if people are really paying attention here and understand that if I put a high number here, then all of a sudden my dysprosium level or my terbium level shoots way up, and my magnet's more expensive, and I open myself up to be more vulnerable to supply interruptions or price spikes. This is the time to think about it. And so if we can be a little bit more strategic with our thinking about temperature range, then all of a sudden that trickles down to, well, that may keep me in the neodymium iron boron family, but maybe my grade is a little different choice, or maybe samarium cobalt gets in there and can do the particular job just as well as neo, and maybe there's some advantages to that. But again, of course, it's always good to optimize to use the minimum amount of material. When I talk to investors about magnets, one of the things I always tell them is that every time I've ever opened a hard drive, it has a magnet in it, usually two. They're always smaller than the last generation that I looked at. And I said, well, people, if they get enough bites of the apple, if they get enough attempts to design something, they can usually figure out a way to do it with less and less and less. And finally, by the time it's very mature and all the way out, they've done a really good job. But this whole process is a much faster way to try to resolve or help some of the resource problems or coming up with new raw material supplies. Just because this is relatively quick and it affects things in the future for the lifetime of the product. So it's a very nice way to go. And to add a little plug for something that's not here, if you want to think about recycling at this point and how you're going to liberate the magnet for future recycling at the end of its life, good for you. I think that's the place to do it. People always want to talk about pricing when you say you have a market study. And of course we have. The point I want to look at here is really the connection between raw material pricing and our ability to forecast. The growth rates that you saw on the earlier slides really come from our projections. And our projections actually have three scenarios: optimistic, pessimistic, and most likely. The ones you saw are from the most likely ones, and there's an assumption built into them, all of them, and it really goes back to over the next 10 years, how stable are raw material prices going to be? It's one that we cannot answer. Like everybody else, we have to watch and see what happens. But we understand, and we can tell you that to hit the optimistic or even the most likely ones, raw material prices have to be relatively stable. They don't have to be high, they don't have to be low, they have to be stable. And that's why this word fluctuations, I think, comes up a couple times in this slide, because that's really our enemy. And of course, how do we control that, or how do we work with it? We can start to think about price fluctuations for raw materials. I define it kind of as really a dislocation and upset in the supply versus demand curve. And if you want to break it down a little bit more, you can say, well, sometimes these things are externally caused, and sometimes they're internally caused. What do I mean by that? Well, external means that it's usually by political or some other outside event. Heavy rare earths are getting a little bit hard to get out of Myanmar these days because there's been a coup there. In the past, we've seen price spikes in the rare earth industry in general, circa 2010. And if we go back farther, there have been, I think, two or three cobalt price spikes that usually go back to some political unrest in the Democratic Republic of Congo. But those are external. Often there's not much you can do about that. Try not to make it any worse than what it is, but there's not a whole lot that most of us as either sellers or users of raw materials can do things. The thing I'm going to talk about, though, is the internally caused ones, and that we do have some control over. But the key connection here, remember, is our forecast depends on the pricing of raw materials. There's no escaping this. And because we can't see what's going to happen, we can only tell you why you should be on guard, I guess. The thing that we see that we would really encourage the industry to adopt is better coordination between producers and consumers of various raw materials, and even further downstream. It really comes into forecasting. When I started to write this section, and one of my co-authors reminded me that in one of his jobs, he was an early supplier of magnets to the disk drive industry, and it was notorious for 1 week they would call and say, you must send everything that you possibly can, and then the next week they would call and say, no, we don't need it anymore, please stop. And of course, in some ways, it's like driving your car where you alternate between you're either floored on the gas pedal or standing on the brake. And that's really not a nice way to go anywhere. A much smoother ride is much easier. And that's really what we're pushing for, is the idea of trying to coordinate between producers and consumers. The one example I'll throw out is when I was at Molycorp, we every month we met and we discussed a 3-month rolling forecast for our major products. And if it was one that I was selling, I would have to stand up and say, well, next month I expect to sell this much to this customer, this much to this customer, and I would lay out what my expectations were. And I was pretty much honor bound to deliver on that, or perhaps to come back with a really compelling story on why that was missed. It wasn't happy if that happened, but it allowed us to give the plant heads up on, hey, this is what you need to do. And if they were going to have a problem, they would need to discuss it. And we really need this kind of between companies, not within organizations. Within organizations, it's good and it should happen too, but it really needs to happen outside, all the way up and down the supply chain. And why do I say all this? Well, if you think about the raw material supply business, rare earths and others, very capital intensive. People don't make investments there casually. They think about returns over the course of decades, not quarters. And so it's very, very important for them to understand as well as they can how much they're going to need to produce over, say, a decade. And if they miss, they run the risk of a price fluctuation. And again, either way, either high or low prices are both bad for different reasons. High prices, I think, are obvious to anybody who buys things that, well, I don't want to pay too much for it. Okay, I get that. That's fine. Low prices are just as bad for the producer of raw materials, because who wants to invest in a company where you're guaranteed a low rate of return for the next decade? I think you'll look around for something else. And so people won't invest in these businesses. What they're looking for is a steady return. It doesn't have to be a high number. Obviously, they don't want a low number. They want something that's kind of in between and sustainable. So driving your car at a moderate speed consistently, rather than hitting the brake or the accelerator all the time. Well, to conclude, I would say that the coming decade can be a very good one for our industry. And can's underlined in this because the lawyers might have inserted may or should be or some other phraseology, but I say can. But we have to be careful here. For this to happen, we have to remove the uncertainty. The uncertainty is price fluctuations and availability of materials. And it's going to require openness and a degree of candor that people probably are not used to having in this industry, but that's where we think we need to be. I'd like to thank you very much for your kind attention. There's a link to our report if you'd like more information, and I'm very happy to have been here with you today. Thank you very much.